Thank you, everybody. Appreciate everybody coming here. My name is Josh Richman. I'm going to go through how our company has changed or evolved its data stack over the years. Part through conscious decision making, part through merging and acquiring other companies and trying to grow as a broader ecosystem. And happy to take questions as they come. We'll also save some time in the middle and towards the end or at the end for additional questions too. So feel free to pop in. Yeah, let's get started. So this is the agenda we'll go through. I'll first tell you a little bit about who I am. And then I'm going to break this up into three sections about the company that I'm currently at. So as I'll mention in a second, I work for Flash. But over the last 4 years, we've seen a lot of growth and changes in the company. When I came, it started as a company called Parkwhiz, which was really just focused around parking reservations and helping people find and pay for parking ahead of time. We evolved a bit as a company to try and broaden our scope to be more of a mobility company that's focused on powering parking whatever way that needs to be done. So helping to kind of power the pipelines behind it, working with a lot of partners to help enable them to allow their customers to reserve parking without necessarily the Parkwhiz brand being up in front. And then most recently, we've joined with a group of companies, primarily a company called Flash Parking, in order to really broaden the scope of what we provide in the parking mobility industry. We'll talk about that in a second. And then after we go through all of those different data stacks we've had, I'll wrap it up with some areas where I expect the data stack to grow and where I think we have a lot of opportunities. So quick intro to me. Senior Manager of Business Analytics at Flash. We are currently hiring, so at the end of this, if you like what you see and you're excited to participate, feel free to let me know. Throw something up in the Operational Analytics Club, our Slack channel, and happy to give you some more details there. But I come from a psychology background, so have a couple of degrees in experimental psychology. And then have had about 10 years of startup analytics experience in one capacity or another. So started with a company called ecomfort.com, where I was the first marketing hire there. We eventually got acquired, and through that process, I realized that I was much more interested in the data side of things than the tactical marketing side of things. So I moved on to a more specific data type of role at another startup called Wisant, which is a tutoring marketplace for students and tutors across the world to find each other. Really exciting place. Stayed there for another few years, and then about 4 years ago, as I mentioned, moved over to Parkwhiz. At Parkwhiz, when I joined, we started at about 100 people. Since then, we've moved to about 700 full-time, 1,000 total people across the company. And we were recently valued at over $1 billion. So really exciting growth there, and a lot of changes, as you can imagine, over time. So let's start talking about some of them. So what is Flash? So Flash is at its core a parking and mobility company. And the way we talk about it is that Flash powers the transformation of connected mobility through the modernization of parking assets. So yeah, you might say parking sounds pretty boring. It's actually a lot to parking. It's can be a bit more interesting than you may think. So I'm giving this context just so that the rest of what we're talking about makes a little bit more sense. Flash does this through a few different avenues. So one is through Parks hardware and software. So Parks is an acronym that refers to the equipment that allows you to operate a parking garage. So you can think of that as the kiosks, excuse me, the kiosks at the entrance of the garage where you might pull a ticket in order to open up a gate and get in, or where you might make your payment, the gates that actually go up and down, any enforcement that's required to make sure that people do pay and don't leave before they pay, and valet. So instead of just taking paper tickets, having a software that allows you to track those valet tickets and transactions, as well as digital and hardware to allow you to be more efficient at processing all of those transactions and cars as they come in. We also have the demand side of things, so digital discovery, payment, and access. So that includes parking reservations, as I mentioned a minute ago, scan to pay, which is our latest technology, which allows you to scan a QR code or an app clip code to have a really seamless experience without the need for an app to pay for your parking with just one click, often using Apple Pay or Google Pay. And then things like BLE and LPR. So BLE being Bluetooth, LPR is license plate recognition, as well as a variety of other really cool advanced technologies to make the parking experience incredibly seamless. So as you're trying to get into a parking garage, not having to reach out your window and try and reach to grab that ticket to pull it out in order to open the garage or press a button, but be able to just tap something on your phone or even have the gate open automatically because it recognizes who you are. And the third section here is connected mobility hubs. So enabling EV charging and having that be a seamless, connected, integrated experience with the rest of your parking and other activities that happen at the parking garage. Supporting fleets as they move in mass from one place to another and need a place to keep their vehicles when they're not in motion. And more to come in this section too. So, okay, let's get down to what we're really talking about here. So, Parkwhiz, the beginning of our journey. So, Parkwhiz, really the main thing. This was an app and a website, and it allows you to book a reservation via an app or web. So, we started with a relatively basic data stack here, and this, as well as the next one, you'll see are a bit older diagrams. And not everything that I'm going to go through here are decisions that I made. A lot of this was inherited, but I can try and give some of the intuition as to why we brought some of these and what some of the issues were that we saw down the line. So as you can see on the left, we have our four main data sources. So the first one is a Postgres database, which is where all of our transactional data would come through. So when someone is purchasing a reservation and making a payment, all of that information is stored in this Postgres database, as well as all of our administrative data. So information about our parking locations, information about the operators who operate that garage that we end up needing to pay some commission to at some point. Things like that all show up in there. We're also bringing data from Mixpanel, which we were using to measure user engagement and user activity on our app and website. We had another app called Best Parking, which we acquired, and they had their own database, which was a MySQL database, and that was their transactional database. So both that and our Postgres database needed to be combined to represent the full transactional picture for the company. And then we also brought in Google Analytics in order to look at how people were finding our website and finding our app. So all that data was brought in through Fivetran into Amazon Redshift. So Fivetran was basically being a really dumb, in a sense, tool here, where it's literally just pulling data from one source, making sure it pipes through cleanly into our data warehouse, which we were using Amazon Redshift for and still are. So I'm emphasizing this dumbness because we do get a little more advanced as we go on. And then once that data dumps into Redshift, we needed to do something with it because all that raw data is not going to be that helpful. So we wrote SQL scripts and some bash scripts to help have these SQL scripts run on a regular basis using cron jobs. And that was our ETL process, which was kind of a raw state of an ETL process to make sure that we had tables in Redshift that modeled our data appropriately, had it aggregated at a level that made sense for analysis. And then we could put that data into Looker, which we used as our BI tool. Now, we'll go into some pros and cons here. So in terms of pros, this is a really simple setup, right? We only have a few data sources coming in. We don't have a lot of complicated work around manipulating this data. So this was a really nice, simple setup with not a lot of things that can break. We're also using a lot of out-of-the-box tools here, right? So we're using Google Analytics. We're using Mixpanel in order to collect all this data and structure it in a way that already makes a bit of sense before we do anything to it. So let's talk about some cons, though, because there's definitely were some. So vendor lock-in is one. If anything ever happened to Mixpanel or anything happened to Google Analytics, which, as many of you who use Google Analytics know, where Google Analytics is going through some changes now and switching over to GA4, it creates a bit of hassle making sure that data can connect. So let's say for some reason we needed to drop Mixpanel and we decided to go with Segment instead. Suddenly we need to be able to connect all of the Mixpanel data to the Segment data, or else we would have lost years worth of user data and not understood our history. So that was a fear that was certainly there. And it also started to get pretty expensive, to be honest. So we'll show our solution for that in a bit. Lack of flexibility was another con. So because we are, because we were using 5-tran in a pretty dumb way, there wasn't much scheduling or creativeness we could do with how we brought this data in. And we, when we use something like Mixpanel, there's only so much you can do to define the events that are getting brought in, the types of activity that are being tracked. So we wanted to allow ourselves to have the ultimate flexibility to track user engagement in the way that we wanted that made sense for our business. Data fragmentation is also another big one here. So you might notice that marketing and sales tools don't show up on this chart whatsoever. So anything that was happening in HubSpot, anything that was happening in Salesforce, or I don't think we were using Salesforce at the time, but really any of these additional tools, Braze or MailChimp, none of this is showing up in here, which means that it's not connected to any of our transactional data. So all of the data that's being used by those teams is kind of being isolated. They're looking at their own stuff. It's not going to show up in Looker connected to the rest of this data. So we can't be as intelligent as we want to be. And the last one here is non-scalable ETL management. So because everything is written in bash scripts, which are not really stored in a structure and in an environment that allows for really building out and managing our ETL process, we felt it wasn't going to be good for scaling our company, which was growing at a pretty rapid pace. So eventually we started to evolve to what we called Arrive, and that became our umbrella company name. Parkwhiz still exists. It's still the name of the app. But we viewed ourselves as Arrive, which meant that we weren't just parking reservations, right? We were trying to start to enable people to make on-site digital payments. We were powering a lot of partner parking experiences. And so this meant we wanted to get a little bit more involved. So what did we do here? So you can see already this is quite a bit more sophisticated than we were looking at before. And we'll start with the left-hand side here. So instead of using Mixpanel, we switched to using our own proprietary analytics system. So what we did was our user events were being sent via, or are being sent via just JavaScript from the client into an Amazon EC2 instance. And you can see because we're using Amazon Redshift, we're kind of keeping everything within AWS. It's all Amazon products. So this data would go into the Amazon EC2 instance, which then makes its way into Amazon DynamoDB. And then from DynamoDB, we use Firehose in order to get that data into S3, which is the Amazon tool for storing data. It's just a file system, but is built to work really well with Amazon Redshift and allow transfer data really efficiently. And then, the reason that we decided to go with Dynamo is that it scales really well. So as we knew we were starting to get more and more users on kind of an exponential level, we wanted the ability to scale up those servers in that database to accept as much data as we needed and send it as quick as we needed into S3 and then eventually into Redshift. And then you can see that we have a direct send from S3 into Amazon Redshift, but we also have Airflow sitting in the middle here. So Airflow is what we use to manage our ETLs, and this solves that scalable problem that we were having before. So instead of just using some random bash scripts that were floating around, we have Airflow sitting on top here, which connects to our GitHub repos. And in GitHub, we have stored a slew of, let's say, 100 different scripts. I forgot to count right before I came. All SQL scripts. And those SQL scripts are managed by a Python script, which is read by Airflow and converted into a DAG. So a DAG is a directed acyclic graph, which I unfortunately didn't grab a picture of and put in here. But the idea is Airflow is handling all of our dependencies, right? So we have a lot of SQL scripts that are processing our data, modeling our data in different ways. And you might need some of that data modeled first before the next script takes it and uses that data to model it again. So Airflow does a wonderful job of making sure that each script runs before another one that's dependent on it. And that's been a real lifesaver for us because manually having to dictate all of that can become incredibly cumbersome. And Airflow does a great job of automating it. We're also bringing in here the marketing tools that you see above. So finally starting to bring that into our system so we can tie everything together. And that's all going into Redshift. Now, some of the uglier stuff starts to happen down here on the bottom. So some of this comes from the idea that we had to create a user-friendly user interface for non-data teammates to interact with data. Now you'd think, well, we have Looker for that. But there were some types of data that we wanted people to use in a different way that wasn't just making charts, but maybe running some queries against more real-time data that we felt we couldn't achieve through the way that Looker was working. We wanted a way for people to enter in their own data manually if they needed to and update our database with some values in a way that wasn't going to ruin our database and it was protected. So we built something that we called Cuttlefish. Our data engineering team was responsible for that, and they built out, using a whole lot of tools here, this UI. And it really was pretty nice, and it worked really well. Unfortunately, it's using quite a bit of toolage here, and as you can imagine, that can become quite a bit of a hassle to maintain. And to continue to update. So one more thing I'll bring up before we go into some of the pros and cons is this is a real whiteboard here. I'm slightly embarrassed to show it, but it's also something that I'm kind of proud we achieved. When we were trying to establish a single source of truth for our parking location data, we knew we had data all over the place and we needed to find a way to combine it. And as we started to grow as a company, we had all these different tools with location data in different places. And so we needed to figure out a way to combine all of that, update in this source, update in that source. And it became incredibly complicated. As you can see in here, we have 7 different sources of data that we needed updated sometimes from one source to another and then back to that source once we've had additional data updated. Not a simple system. My favorite part of this is that I noticed we have this some guy in the corner who seems to be in charge of all of this, or at least we're hinging on some guy to do this right. So obviously not the most ideal way to have this set up. I think there are some tools out there that might facilitate this in the future if we need to do it again. So let's talk through some pros and cons of this stack. The pros were this ETL and DAG management that we talked about with Airflow, incredibly simplified. It's been working really smoothly. Pre-deploy testing. So as you may notice in this DevOps tools and utilities section, we reference Jenkins. So at one point we used Jenkins and another time we used Drone. We integrated these with GitHub so that whenever we would have a change in our code that created a pull request, when that pull request would go up into GitHub for review, we would have Jenkins or Drone automatically check our code to make sure that nothing broke syntactically, that the whole script would actually work. And it also would check downstream to make sure that any columns that were referenced in the tables that were creating or updating in that script were not going, or we're not going to break anything downstream. So imagine we had one script that we're making edits to, and then a script downstream that refers to a column in that table. Well, if we change the name of the column, then we're suddenly going to have something break. So Jenkins and Drone were making sure to check in on that and let us know if there was going to be an error downstream. That was really great. I'll say, unfortunately, when COVID came, it really hit the parking industry pretty hard, which meant that we lost a lot of our team. Our analytics team went from about 8 people down to 1 person, which was me. So we lost all of our data engineering team. And so a lot of this, which you'll see as I point out in a second, is pretty unstable, right? So a lot of these custom products require maintenance. And when you don't have people to maintain them, then they all go away. So the moment that we lost our data engineers, that cuttlefish program I was talking about that represents this whole side of stuff on the bottom here, it broke instantly, of course, and there was no one there to fix it. So we kind of lost that tool, and there was no way to recover that in the end, because no one knew what the heck it was, and the code was very difficult to parse through and figure out how to fix. So similarly, Drone and Jenkins were tools that were working well as our data engineering team fell off, and before we were able to grow them back on, those tools also devolved, and we're still working to bring something like that back in a more robust way. Another con here was just increasing the need for cross-tool orchestration. So as you noticed in that giant diagram, bringing on HubSpot, it was kind of a mess trying to link everything together. As you see here, we're bringing on all of these different marketing tools. So making sure that data going into Redshift and potentially data going out of Redshift are all syncing in a way that makes sense. Definitely a challenge there. I'm gonna keep going through, and I will get to some of these questions as we get to the end. So Flash. So now, as I mentioned, Flash evolved to a bit more. So we have payments and on-site digital payment, or demand and on-site digital payments. We also have these parks equipment, and we have manual and auto enforcement of parking lots. So manual being walking around with a handheld device where someone's typing in your license plate and making sure that you should be there. Auto being we have a camera that's at the entrance and the exit that's checking your license plate as you come in and out and making sure that you've paid for your time there. And electric vehicle charging as well. So we're getting a lot more complicated with a lot more data sources. So this is what our stack looks like today. For the most part, there's a little bit that's missing. It's a bit wider, and it's a bit cleaner, I think, even though there's more going on here than what we saw before. So if you notice a difference here, the stacks that we saw before were all very centered around Redshift, right? So if we go back to something like this, we have Redshift in the middle and everything is kind of clouded around that. So this and the previous stack were, or this image and the previous image were created by one of our previous data engineers. And I think it makes sense to see it this way, because as a data engineer, your goal is to get data from point A to point B. And here, point A being any of these external data sources to point B, which is our data warehouse. So everything's centered on getting data to the data warehouse. However, as we've really started to grow as a company, it's become much more important to kind of refocus that thought. So we want to make sure as a data team, we're not thinking about just getting data into the data warehouse. That's not the center of life, right? The center of life is where that data is being acted on. So in this representation, it's a little more clear that we're focused on getting data from the left all the way to the right. So the left is where our raw data lives. And as we go through, we hit Amazon Redshift in the middle eventually. But then we also move that data on, right? We're moving it on to Looker. We're moving it on to Slack and emails. We're moving it on to S3 at times to send data back to be stored. We have SFTP connections with our partners to send them data. We send data into Braze. So not only are we getting data from Braze, but we're also sending data back into Braze in order to operationalize that more. And we have a partner portal that we're working towards getting data integrated from Looker as well. So just to go over this a little bit, because it's quite a bit different. At the top, we still have that marketing section, right? So all of our marketing tools going from their sources through Airflow, sometimes into S3, and then into Redshift. We have our product engagement, which is the same as before. So our apps and our websites going through Airflow into Redshift. And then on the operations and finance side, so kind of like our transactional data and our admin data, we have a bit more data sources here. And so this is where it gets a little more complex. So this little icon is Arrive. So this is where I was coming from. And we have our Postgres database that we mentioned before. And all that data is coming from Postgres. Some of it's coming through, being managed through Airflow. Most of it is. Some of it's being managed through Fivetran. And we made that decision because, as I mentioned before, Fivetran was being pretty dumb about this transfer. And there are some tables that really don't need much translation or changes as they come through. So we've kept them moving through Fivetran. But the rest we've moved into to be managed by Airflow because we do a little bit of translation and modeling before that data gets into Redshift. And also because, as I kind of mentioned before with Mixpanel, Fivetran can get expensive, similar to Mixpanel. So we've been trying, as you've seen generally here, to move things to be proprietary and in-house rather than rely on external tooling. And I imagine eventually one day we'll move completely off of Fivetran, is my guess. We also have these other icons here that you see. So this icon here is the Flash logo. This is Park Connect. This is OmniPark. This is ZipPark. All these are different companies that we've either merged or acquired within the past year. And so we're starting to take data from all these different databases and bring them into Redshift as well. So this unification project is one of our biggest this year. It's not been easy, and it's continuing to be a process that we work through. So for example, our Flash data is coming from an Azure database, which then moves into a SQL Server database, which then makes its way to Redshift. Park Connect comes from a SQL Server database. OmniPark, which is our enforcement solution, one of our enforcement solutions, that also is in a SQL Server database. But before we pull it into Redshift, we actually make some views within there. That was done in order to utilize the OmniPark team's business knowledge to clean up their data before it actually makes it through to Redshift, so we don't have to have that business knowledge, business logic in our systems. And then ZipPark is the last one here. They have their data stored on SQL Server databases, but unfortunately, every single one of the locations that they work with is on its own SQL Server database. So we now have to link all these databases together and bring all of those into Redshift as one thing. So it's a really distributed data set, but we're managing it really efficiently through Airflow. And I could probably talk a little bit more about that during question time. And yeah, again, the goal is to bring all of this data on different cadences. So some of this data is updated more frequently than others, and we can handle that all through Airflow. So some pros, independent DAGs. So each one of these data sources is being managed by a different DAG. So since we don't have a lot of cross company dependencies at this time, we're able to say, oh, this data set we can bring in on an hourly basis. This one only needs to come in on a daily basis. And we don't need to rerun every single script every single time in order to get just one subset of data in. We're also using S3 a bit more in order to optimize our data transfer and try and make things happen more quickly. As I mentioned earlier, we're moving data from Looker to Braze, which is exciting and the first step towards really operationalizing our data. And then reports via Looker. So our one last point here to bring up is that our our old so the company that we merged with called Flash Parking also had a way to report their data to their customers, to their clients, which are now ours, and that was all running off of their production database, which meant that those reports took incredibly long to run. That database was not optimized for running reports, and it was being hit by lots of stuff constantly. So what we've done is started the transition of moving those queries that were running on their production database into um, Looker reports. So making sure that data makes its way from the Flash database into Redshift and setting up explorers in Looker, which can then query really quickly against Redshift to generate a report. So as an example, we've been able to take a report that used to take 45 minutes to run each day to only take 45 seconds to run in Looker, which has been pretty amazing optimization. I will move on to the last slide here. And then I see some great questions, so I will jump in there. But just to get through these real quick so we can wrap up, where next? So a few different places where I see we definitely have some room to improve. So DevOps is the first one for sure. I mentioned before that we were using Jenkins and Drone to do this before, but not anymore. So we're working towards getting some more unit testing in, as well as some QA environments to make sure that we can test our scripts before we actually deploy them and know we're not going to break anything and understand what the output is without having to manually run scripts in a sandbox schema, which is often what we have to do right now. We're going to move more into data science. So that means building predictive models, which means we probably need some additional infrastructure to support the demand that's going to create. External reporting portal. So this is something I mentioned that we're sending data from Looker into this reporting portal. But what that means is that our customers are looking there for how their parking garages are performing. So some of that data is going to be fine to get there once a night. So they see in the morning, oh, I had this many transactions the day before. But a lot of that data also they want to see in real time. So how many people came into my garage in the last hour? Do I need to make sure that I have the right amount of staff here? Oh, I see we're having a spike in people coming in that I didn't expect, and now we're full, so I need to call some extra support to come in. So we need to figure out that process. Data governance. This is something I've been thinking a lot about lately. I talked about making sure that one script doesn't end up impacting another, changes to one script doesn't impact another script. There's a big gap there that we have, and it takes a lot of research every time we put out a PR to make sure that we're not going to break anything downstream. And it takes even more research to make sure we don't break anything in Looker or in any of our further dependencies. So having a way to do this in a cleaner, more efficient way is something that I want to build out. And then the last one is operational analytics. So I mentioned we're moving data into Braze, but we can do things like Salesforce as well. So our sales team works within Salesforce. They probably don't want to be going between two different tools to understand the types of places that they should be going after, or to get insights about the locations they are making sales pitches to. So we probably want to start sending data from Looker into Salesforce as well. And there are a whole slew of other potential opportunities for things like that. So that's a wrap for what I've got. So thank you very much for listening, and I appreciate the questions that have come in, and I think I'll try to answer some of those now. Thank you, Trevor. Okay, Q&A. And thank you for Parker for hosting, even though we can't hear you. Let's see. Okay, have we considered switching to DBT? Good question. So for those not as familiar with DBT, and I'll kind of go back up to here. I don't have an expert level understanding of DBT, but please, Wesley, let me know if I'm incorrect here. But generally, DBT is the product that allows you to create business logic and data models outside of your actual database. So you have an extra layer that can dictate logic and define metrics and dimensions that then are used against your database as you're querying it in other systems, such as Looker. I've thought about maybe moving there. I haven't personally seen what the full benefit of that would be. So all of our business logic is held in two different places right now. We have our business logic held in our uh, SQL server, SQL server, sorry, in our SQL scripts that are our ETL process, and we have a very extensive one, which is why undoing that would be rather complex at this time. And once that data has been cleaned up and aggregated, we have additional business logic that's held in Looker. And Looker's where we're really defining what a lot of the metrics are, how we define um, different aggregations and make sure that they're consistent across different places, but also make sure they're different where they need to be different. So if one team needs to see a metric in one way and another team intentionally needs to see a metric defined a different way, we can do that within Looker. So I haven't felt a need to do that yet, but happy to learn more. And I've been starting to dive a little bit into trying to understand what DBT can do, but I haven't felt that it's been necessary at this time. There's a question from, I guess I'm going backwards, aren't I? There's a question from Steven. Curious which GA customers are switching to 4 versus using this as an opportunity to leave GA. That's a fantastic question. I don't have an answer. As you'll notice here in this stack, GA doesn't really appear. So because we still use Google Analytics for sure. We primarily at this point use it in 2 ways. The marketing team will still, I think, look in Google Analytics to track some metrics. I really don't even know so much if they're using it very heavily. Primarily, we use it for making sure we're grabbing things like. Actually, I take it back. I don't think we're really using it very much. So, because we are using our own internal tracking system for user events, that means we've also developed out a complex way of tagging individual users and recognizing them depending on where they come from. So across device and things like that. And then as long as we're using UTMs properly within our URLs as people are coming here, we have SQL scripts that are then translating that properly and categorizing things and attributing based on our attribution models, attributing visitors to one source or another, attributing transactions to one source or another, which might be different than what we attribute the user to. And because we're using Looker and have things modeled pretty well in Redshift, we don't really need Google Analytics for the most part. You can make most of the charts that you would be able to make in there within Looker, and other things you can pretty easily query if needed. So I don't have a great answer for that, but I could definitely see that this would be a good opportunity to leave GA because I've heard that the switch to 4 is not necessarily the simplest thing. And it's prompting me to ask my team what we're planning on doing with it because I haven't used that data for a while. And then Brian asked, in the Flash data stack, how are transformations done? So I think I kind of touched on that a little bit, but when we were talking about DBT. But what's happening is that we have these raw data sets that come in from Arrive and Flash, et cetera. They make their way into Redshift. And so we have schemas that are set up for each of these data sets. And they contain all of the raw data. So the way that our data team is structured is we have a data engineering team, and their job is to just get that data from point A to point B. So get it from the external source into Redshift. And then once it's in its raw state in Redshift, that's when my team takes over and we write out SQL scripts to transform that data. And that might be just cleaning up the data, redefining or grouping different labels, filling in values if they're missing and we need them for a business reason, or excuse me, combining data sources to get a clearer picture of what's going on, what a user is, what a transaction is. So those are SQL scripts that are being run to do that on a nightly basis, and eventually we'd like to get that at a much more frequent level. For some of our data sources, that does actually run on an hourly basis right now. But for the Arrive data set, that's running on a nightly basis. And all of those scripts are managed by Airflow. I think that's all that was asked from the group. Oh, nope, it's not. There's more. Um, are we using managed airflow or self-hosting? Good question. So I believe we are using managed airflow. I don't believe we are self-hosting right now. It could be wrong. Oh no, I take it back. We must be self-hosting because we are using Docker to allow us to host an Airflow server, and then we're using excuse me. So yeah, so we pull down a container for actually this is interesting. So from a data engineering perspective, um, we do have an Airflow server. We use Docker in order to pull down a container for the Airflow server. And then instead of installing everything from Airflow onto our EC2 server, we just install everything in this container from Airflow. And then we use all of Airflow's defaults and just code whatever we need to change. Because from what I'm told by our data engineering team, we actually have a lot of or Airflow's code and is relatively complex. There's a lot of different things you would need to install. So if we were to have our own server that, like our EC2 server that um, had Airflow installed once, and then our changes were made, and then whenever Airflow changed, we would have to go in and make changes and figure out how to update that code. Um, it's a lot easier to just pull down a container that has the most recent Airflow um, code in it, and then make whatever small changes we have to it to customize it the way we want. So I don't know exactly how the Kubernetes structure is set up, so hard for me to answer that. But that's the best way I can answer that question. Hopefully that's informative. Then the last question I see here is, are we running tasks in their own containers for Airflow? So I don't believe we are running tasks themselves in their own containers. I think it's all happening in that single container. But that's a better question for me to follow up and get back to you on if I can, because I don't have a detailed question for that or detailed answer for that. That's more managed by our data engineering team. We do try and separate our tasks as distinct as possible, but mostly that's for being able to debug when things break and make sure that we can run things incrementally and modularly, and not have to start everything over if something in the middle breaks down. Any other questions coming through? Sure. Good question from Nicole. So the difference between Tableau and Looker. So yeah, if you can see here, we do send data to both Looker and Tableau. It's a great question. So the way that I see it, both tools are really great, but for different reasons. So Looker has a really nice, easy to use UI for stakeholders that aren't as technical, or maybe not as data savvy. Excuse me. The ability to really easily drag and drop fields to create a chart and make a dashboard in a really simple manner, um, I think is a lot cleaner and easier to understand and use than Tableau. And the way to connect and reference data sources in Looker, to me, is a lot more intuitive and makes a lot more sense from the end user's perspective. So rather than having to search for different data sources and try and connect them and make my own joins, um, I try and leave people to not have to do that. Like that should be a data team thing. So we've set that up in Looker and really built a lot out in Looker to support the combination and joining of data sources. So for stakeholders to build their own reports easily, for us to schedule reports to non-Looker users, so to external users, Looker's been fantastic for supporting that. Tableau helps fill in the gap for Tableau, the shortcoming of some advanced visualization capabilities that aren't really available in Looker. So Looker doesn't really do maps very well, in my opinion. It's not very clean. Sometimes it can be really slow. Tableau has a really great mapping interface. And because we are a geographic company in that we have parking garages across the country and in Canada as well, and we need to really understand the interaction between distances, between people, between garages, between points of interest in garages. Being able to visualize that on a map makes a lot of sense. And we've been able to build out really cool, interactive, highly developed data products within Tableau that we just really couldn't do within Looker. So there are some other more developed dashboards and cool capabilities we could do in Tableau as well. So that's really how we differentiate it. Tableau is for advanced data products and interactive tools. Looker's more for internal stakeholder report building and automatic report scheduling for external customers. Another question here was from Brian. So Brian, you were saying, Airflow is a scheduler. So is it also moving data analogous to 5chain in the chart? Yes. So yes, it is a scheduler. It is moving data, but I think the key difference for me from a business analytics standpoint, I'm sure the data engineers have another perspective as well. But for me, the big difference here is the ability to really manage dependencies in a clean way. So I was referencing this idea of a DAG, right? A directed acyclic graph, which is showing how all of your SQL scripts need to run in a certain order in order to properly model your data, transform your data without skipping any steps. And Airflow handles that in a really seamless way. So there's basically one file, it's a Python file that you just list out what your dependencies are. And if I say that A is dependent on B and B is dependent on C and C is dependent on D, and I also say that B is dependent on D, even though I skipped a step within there, Airflow is able to figure out and interpret what the right order for all of these scripts should be so that they run in the proper way. And it doesn't allow you to create cyclic dependencies so that A depends on B and B also depends on A, which is going to cause horror when you try and run all these scripts. So Airflow is able to automagically make this really cool graph, which for us looks incredibly intense. There's hundreds of lines that are circling through and showing how everything depends on one another. I'm not sure that 5chain, personally, I'm not sure if 5chain can do that as well. So yes, similar to 5chain in that it moves data from A to B and that it can do that on a schedule. I think Airflow allows a lot more flexibility in how you do that and how it gets managed. Let's see, a few more questions. And yeah, Wesley, I think you're pretty right on what you said there about the Python functions that Airflow is calling doing the data transfer. Yep. So, and I guess to be a little more specific there, right? The Python scripts that we have that Airflow is calling are referencing SQL scripts that we have. So not only is Airflow taking data from point A to point B, but it's saying, okay, I'm going to do this task. This task is not just move it from here to here, but it's also to do this transformation that my SQL script is instructing me to do. Trevor, you asked a question about using Looker as a data integration tool. What does that look like? So the way that we're using it for data integration, I think you mean like sending data back, making it operational. Is that what you mean, Trevor? I'll wait for a response from you on that. Like how we're sending it to Braze? Okay, cool. So Looker has a few options that are already integrated within Looker that are available in Looker's marketplace that you can send data from one place to another. Let me take a drink. The way that we use it, I guess we send data to a few places. So one place is Slack. That's a built-in ability. I don't know if I'd call it integration as much as you can use it for alerting, which is really nice. So you can use it for based on thresholds. So if something is above 10% change in the last day, and that's a really big thing for you, you can set up an alert and it can send that out to Slack to a specific channel or a specific person and let everybody know that something's going on. You can also send it to things like Braze. I can't remember if we don't really use it for anything else right now because there aren't a lot of integrations built out yet that to things that to other tools that we use. But for Braze, it's pretty simple. So um, the way it works is that Braze is, for those who don't know, Braze is an email tool, basically a CRM, and allows you to email to your customers, create segments based on flags that you set up for your users. And the way that we use this integration is we use Looker to define what those flags are so that we can automatically segment our users in Braze and put them into different automated email drip campaign channels. So for example, we can create a look in Looker that says, give me a list of all of the users that are that have had 3 transactions in the last week. So really frequent parkers. And we can have just have a list of users and then have that report scheduled to send out to Braze at whatever frequency makes sense for us. And when it does that, there's really just a couple of fields that you put in. It was really simple to set up with my friend on the marketing team. And it then it appends a flag or a tag to those users within the system based on whatever we decide to call it. So we want to call these high frequency users, it'll update that. And then if something changes for that user, then we can set up a report to say we want to send a new flag for a new value for that flag. Say instead of being high frequency, maybe they're medium frequency now because they haven't had a booking in the last couple of weeks, something like that. And you can make it really whatever complex filtering and modeling you want in order to figure out who your list of customers are for that segment. But once you figure out the segment, it becomes really simple to just send a tag over to Braze. So Braze doesn't have to do any of the thinking other than sending stuff to people. Cool. I think the last question here is we've got just a couple of minutes left was have I ever worked with holistics? Pros or cons of Looker versus holistics? So a good question. I've not worked with holistics. I've looked into holistics. So I don't want to say too much in terms of capabilities. I felt there were certain things that I was not really ready to make the leap to switch over to something like holistics. We weren't necessarily looking to switch from Looker, but there was a tangential need or potential need for another BI tool to interface in a different way. And holistics was a candidate for that. We decided not to go with it at the end of the day. That was more honestly me having some concerns about some of the capabilities that just weren't fully fleshed out yet because holistics is a slightly newer company than Looker, I believe. And yeah, I think it came from that. I could check in my notes and you can contact me directly if you'd like some more details on what my evaluation was. But I haven't actually used it in the field. I've used in the past Chartio, which is no longer here as they were acquired by Atlassian. So anyone who's using Jira or Confluence, go check out their new analytics tools. It's supposed to be really cool, all based on Chartio stuff. And then, yeah, Looker and Tableau as well. Cool. Yeah, so I guess last pitch here that Parker threw in the corner, and then maybe we'll close it off. Operational Analytics Club has summer community days in a couple of weeks. So check out that link that Parker just posted on the screen. I am one of the speakers. I'll be talking a bit more about my path to a data career and how that came about. I personally find it a little interesting. Hopefully you find it very interesting. And yeah, there are a lot more besides me, 40 speakers speaking. It's going to be a really great event. There's a lot of really cool topics being covered. So please check it out if you haven't. And yeah, that's our show. Thanks everybody for coming out.